All right, this is assignment number 7, and it's kind of a long one, so let's just get right down to it. First problem, explain why the integral is improper and determine whether it diverges or converges. Evaluate the integral if it converges. So this is an improper integral. I didn't erase this part because 1 over radical x is undefined at x equals 0. And so we need to use limit notation to let a approach 0. We would be approaching 0 from the right. That's where the graph exists. So times the integral from a to 4 of x to the negative 1/2 dx. And then that, let's see, does it converge or diverge? Remember, it's not a p integral because it's not going to infinity. So we need to just see if it converges or diverges. And I know that the limit notation can be really annoying to write, but we just kind of have to do it. If you always do it, then it won't be so bad. You won't forget to do it on a free response. So add 1 to this exponent. You get x to the 1/2 divided by 1/2 from a to 4. Keep your limit notation. So this is 2 times radical 4 minus 2 times radical a. 2 times 2 is 4 minus 2 times 0. Because I got a numerical answer, it means that this integral converges, and it converges to 4. All right. This is an improper integral because x equals 1 is where there's a discontinuity. There's a vertical asymptote here. So we would need to split this into 2 integrals. It would be the integral from 0 to 1, but let's go ahead and make that b. The limit as x approaches 1 from the left of 1 over x minus 1 squared dx. Add to that, this is going to be the integral from 1 to 2, but we can't say 1. We're going to say a. We'd be approaching a. Oh, sorry, wait. No, yeah, this is right. Sorry. Approaching 0, not 0, approaching 1. There we go. Approaching 1 from the right. I always picture that I'm here in the integral and I'm approaching it from the right, and here I'm approaching from the left, so I'm coming at it. Of 1 over x minus 1 squared. Sorry, I'm a bit congested. That's why I keep taking these pauses to breathe. Okay. There technically is u sub happening here. U is x minus 1. However, du dx is 1, so we don't really need to make any major adjustments. Just treat it like a 1 over u squared. All right, so this is going to be the limit as I said x back here. I meant b, excuse me. Limit as b approaches 1 from the left of 1 over u squared, so u to the negative 2. That'll be u to the negative 1 over negative 1, or negative 1 over u, which is x minus 1, from 0 to b. Add to that the limit as a approaches 1 on the right of the same antiderivative. We're going a at the bottom, 2 at the top. Here's me just plugging in my numbers. Oops. Sorry, I am really all over the place here. Okay. Negative 1 over b minus 1 minus negative 1 over 0 minus 1. And then the limit as a approaches 1 on the right of negative 1 over 2 minus 1 minus negative 1 over a minus 1. Negative 1 over 0 is negative infinity plus 1 over negative, so minus 1. Negative 1 over 1 is minus 1 again, plus 1 over plus infinity. Ooh, I'm technically getting infinity. No, wait a minute. Is this? Oh, okay. Sorry. I had negative infinity right here. Infinity minus infinity is indeterminate, so that would have been a problem. But actually, this is from the left, so this is like 0.999 minus 1, so that would be negative as well. So this is actually positive infinity. That's very tricky. Infinity plus infinity is infinity. Plus 2 or minus 2 is still infinity. But yeah, if I had infinity minus infinity, that's one of those indeterminate forms that I would have had to do something else to try to figure out what was happening. And I wouldn't have known what else to do. So this integral came out to infinity. That means it diverges. All right. This is an improper integral because there's a discontinuity at x equals 1. So we kind of need to do the same thing that we just did. So the integral from 0 to 1, but I'm going to let that be b. Limit as b approaches 1 from the left of 1 over x minus 1 to the 2/3. I still don't need u sub here, so I'm not going to show that again. Sometimes I set the integral up first so I don't mess this up. So I want it to go 1 to 2, but I'm letting a approach 1 from the right. So no u sub needed because u is x minus 1 and du dx is 1. So no adjustments need to be made. So u to the negative 2/3. When you add 1 to that exponent, you get u to the 1/3. Divided by 1/3, which is 3. So that came out nicely. Same antiderivative over here. Right. Plugging in my numbers now. 3 times b minus 1 to the 1/3 minus 3 times negative 1, 0 minus 1 to the 1/3. Here we have 3 times 2 minus 1 to the 1/3 minus 3 times a minus 1 to the 1/3. Plugging in 1 for b, so this is 3 times 0 plus 3 plus 3 times 1 minus 3 times 0. That looks like 6. So I got an answer for that one. So interesting. Let's just go back. When we had 1 over x minus 1 squared, that higher exponent meant that we had something that diverged. When I have 1 over x minus 1 to the 2/3, a smaller exponent down there, it looks like the graph is approaching its vertical asymptote faster than it was here. See how that's narrower? So then we did get something to converge. So I'm sure there's a rule in there somewhere. We can make our own guess about what we think it is. And then do some searching to see what the real rule is. But yeah, that seems like we're onto something there. Okay, determine whether the improper integral diverges or converges. Evaluate the integral if it converges. So this is kind of a test of all our different types. Do we know what's happening here? This looks like integration by parts, and there's an issue right there. So this is going to be the limit as b approaches infinity of something. And let's go ahead and use the tabular method. When you use the tabular method or the traditional formula, you have to define what is u and what is dv. If you don't get credit for your work there. So u needs to be clear. I'm using Liate to determine what u is. That's log, inverse trig, algebraic, which is what this is. That means dv has to be the e to the negative x dx piece. Tabular method is nice. It's shorthand for the integration by parts formula. What you do is take derivatives on the algebraic piece until you get to 0. So the derivative of x minus 1 is 1. The derivative of 1 is 0. Integrate e to the negative x, you would get negative e to the negative x. Integrate that, you would get positive e to the negative x. Plus, minus, plus. Connect diagonals, loop the bottom. The bottom represents the integral of 0 times e to the negative x dx, which is 0. So the antiderivative here is negative e to the negative x. Actually, let's do this. Negative x minus 1 over e to the x minus 1 over e to the x from 0 to b. And then I can put my values in. Fundamental theorem. That's the first piece. Minus negative 0 minus 1 over e to the 0 minus 1 over e to the 0. Infinity over e to the infinity. Negative infinity over e to the infinity is 0. And then I have minus 1 over e to the infinity, so minus 0. This is minus 1 over 1 plus 1 over 1. Did I just get 0? Yes, I did. This graph down here is representing, like, how did I just get 0? X minus 1 for values between 0 and 1, that area between the curve and the x-axis is negative. For x values greater than 1, the area is positive. So I could be convinced that that net area is 0. So this converges. All right. For this next one, we have 2 issues, improper bounds here. So we need to split this up and look at the form of it. It's arctan. So how do you know where to split it? I would say for arctangent, it's a good idea to either split it at 0 or 1. I usually just go with 0 and then see what happens. So this is going to be the limit. So it's going to be negative infinity to 0. So let's let a approach negative infinity of 4 over, let's see. So this is going to be a is 4, u is x, du is dx. So it's 4. So I guess I don't need to make any adjustments. Sorry. I was thinking I had u sub, but I don't. Plus the limit as b approaches infinity of the integral from 0 to b of 4 over 16 plus x squared dx. The antiderivative here is 1 over a, so 1/4. Oh, wait, there's a 4 here too. There's a 4 on the outside. That's what I was thinking. 4 over, sorry, it's 1 over a. There's a constant of 4 already. So 4 over 4 times arctan of u over a. There we go. Same thing over here. I'm not, well, yeah, I guess I will. Write the same thing. All right. So this is going to be arctan of 0 minus arctan of a over 4. And this one is arctan of b over 4 minus arctan of 0. If you don't remember, the arctangent graph looks like this. It has horizontal asymptotes on the left and the right, pi over 2 on the right, negative pi over 2 on the left. It goes through 0, 0. So that's all the information I need. The arctangent of 0 is 0 minus the arctangent of negative infinity over 4 is negative pi over 2. So minus negative pi over 2 plus arctangent of infinity over 4. So pi over 2 minus 0. That's positive pi over 2 plus another pi over 2. That's 2 pi over 2, which is pi. So this integral also converges, and it converges to pi. Determine whether the improper integral diverges or converges. Evaluate the integral if it converges. And check your results with a graphing utility. I don't know that I'm going to do that, but we'll see. So again, this is not a p integral because we're not going to infinity. We're just going to 1. So go ahead and use your limit notation. The issue here is 0. I'm going to let a approach 0 from, we're coming at a from the right, x to the negative 2 dx. This is x to the negative 1 over negative 1. Negative 1 over 1 minus negative 1 over a. Negative 1 plus 1 over 0 is infinity, so that's infinity. So this diverges. You could check, let's check in Desmos. Integral from 0 to 1 of 1 over x squared dx. So it tells me undefined. It doesn't say why, and so I don't love that. I much prefer to do just do the math here. All right, what about x ln x? So x ln x, if it were ln x divided by x, we could do u sub. No amount of u sub is going to work here. So we need to do integration by parts. Remember, the rule is Liate for what you pick to be u and what you pick to be dv. Make sure you label them. And what is the issue in here? 0. You can't have ln of 0, so we're going to have to replace that. So it's going to be the limit as a approaches 0 from the right. And then we'll see what we get for this. So we need to let u be x. Oh no, sorry. We need to let u be, the reason we can't let u be x and dv to be ln x is because we don't know what the integral of natural log of x is. So let u be ln x, dv has to be x. You can only do one round of tabular method. So the derivative of ln x is 1 over x. The integral of x is x squared over 2. Set it up plus, minus, connect diagonal, and loop around. This is the integral of 1 over x minus, 1 over x times x squared over 2. All right, so for the first part, we have the limit as a approaches 0 from the right of x squared times ln x over 2. That gets evaluated from a to 1. And then we add to that the limit as a approaches 0 from the right, the integral from a to 1 of this integral here. So instead of adding to that, I'm going to do this. I'm going to put the negative out there. The negative 1/2. And then x squared over x is just x dx. So you just do one round of the tabular method, and then that, even though that doesn't get rid of all of your integrals, the integral you're left with should be something that you know how to integrate. All right, so this becomes, before I evaluate over here, this becomes x squared over 2. All right, so this one up here is the limit as a approaches 0 on the right of 1 ln 1 over 2 minus a squared ln a over 2 minus, I'm going to do this, minus 1/4. No, I won't. Plus, limit as a approaches 0 on the right. You can pull constants out in front of limits, but maybe that doesn't make it any easier. Let's just merge this in. Negative 1/4 times 1 minus negative 1/4 times a squared. A is 0, so ln 1 is 0 minus 0 times, oh, did I do something wrong there? Oh, no, I didn't. Okay, 0 times infinity is an indeterminate form, so I'll need to L'Hopital's on that to work on it. Let me write down the rest of this, though. Let's see. From a to 1. Sorry, I'm just trying to check my work here. Oh, never mind. I'm okay. I showed it differently than what I wrote down originally. Okay. Then we do a minus 1/4 plus 0. So it's just this. Is this 0 or infinity or something else? Because that's sort of what the whole problem is hinging on. So we need to do a little bit of L'Hopital's method, because the limit as a approaches 0 from the right of a squared equals 0, and that also equals the limit as a approaches 0 on the right of natural log of a. Actually, that doesn't equal 0. That's just indeterminate form. So we need to work on this using L'Hopital's method. How do we do L'Hopital's again? Well, we do something like, all right, it's got to be rational, right? So let's make this, instead of minus a squared times ln a over 2, let's make it ln a over negative 2 over a squared. Instead of multiply by a squared, I multiply by 1 over a squared, and that puts that in there. And then as we let a approach 0 from the right, ln a goes to negative infinity, and so does this one. Negative 2 over a squared also goes to negative infinity. And when you have negative infinity divided by negative infinity, you get to do L'Hopital's method. So that means that that's equal to the limit as a approaches 0 on the right of the derivative of the top over the derivative of the bottom. Derivative of ln a is 1 over a. Derivative of negative 2 a to the negative 2 is 4 a to the negative 3. And that simplifies to a cubed over 4. So now this limit is a squared over 4. So now it's 0. Okay, so that comes out to something that converges. 0 plus 0 minus 1/4 plus 0. So I got negative 1/4. These problems, by the way, are pretty complex. If we can follow along and you can kind of do this, or you could replicate this now that you've seen me do it, you're in a pretty good spot. I'd be shocked if we had anything kind of this involved on a free response. I did graph this region, by the way, and sure enough, it is a negative area. All right, let's look at 46. This looks like arc sine to me. And what's the issue? Well, the issue is right here at 5. I don't think there's any u sub happening on the arc sine. We just need to take care of that limit notation. So let's let this be the limit as b approaches 5 from the left of the integral from 0 to b of 1 over the square root of 25 minus x squared dx. Remember, there's no 1 over a for arc sine. It's just arc sine of u over a, so x over 5, from 0 to b. That's the limit as b approaches 5 from the left of arc sine of b over 5 minus arc sine of 0. Arc sine of 1 is pi over 2 minus arc sine of 0 is 0. So I got pi over 2. I got that this converges to pi over 2. Confirmed on my graphic calculator there. Okay, determine all values of p for which the improper integral converges. Now, they do like to give us stuff like this for our free response questions. Which one of these is a p integral? The answer is the one that has the bound to infinity. So this is a p integral. P greater than 1 converges. Yeah, that's all I'm going to say about that. What about this one? Well, this one I can't just say, oh yeah, p greater than 1. This one I need to actually I would need to go through and integrate this. So first of all, there is a discontinuity there. So I would say, well, the limit as a approaches 0 from the right of the integral from a to 1. Let's make it x to the negative p dx. That would equal the limit as a approaches 0 from the right of x to the negative p plus 1 divided by negative p plus 1. All right, now what about this negative p plus 1? So we are for values between 0 and 1. So I'm trying to decide if negative p plus 1, I guess I can't say much about that. Never mind, I'll just keep plugging stuff in. We're plugging 1 in for x. So 1 to the, I'm going to make this 1 minus p over 1 minus p minus a to the 1 minus p over 1 minus p. A is going to get plugged in as 0. So this is 1 to the anything is 1. So 1 over 1 minus p minus 0. So I would say this converges. Let's see. Converges. So the answer I get is 1 over 1 minus p. Which remember, it's not a p integral, so it's okay if this is flipped around. Like I was thinking 1 over p minus 1. But do I have to consider anything about this? Let's see. So 0 to 1 of 1 over x to the p is something like this, right? And we need to make sure because whatever it converges to, it needs to stay positive. Like this represents the area underneath the curve. So for example, p can't be 5 because then I get a negative area for this. So I need to make sure that 1 over 1 minus p remains positive. And that would happen if I'm putting it on a number line. If p is anything smaller than 1, this stays positive. If it's anything greater than 1, I get something negative. So any p can be anything. This converges for any p that's less than 1. Yeah, that makes sense. Because if you get negative values for p, like p is negative 5, x to the 5th converges from 0 to 1 for sure because it doesn't have a discontinuity anymore. Yeah, so I'm going to say for any p less than 1. Okay, for this group, we're almost done here. This is a fun little thing. This curve is called the Witch of Agnesi. That's exciting. Find the area of the unbounded shaded region. You could use symmetry here if you don't want so much limit notation. And we want the area, right? So if I don't want to go from negative infinity to infinity, I could just go from 0 to infinity and then just double my area. So instead of this, I'm going to say this is definitely symmetric. It's an even function, so I could say this. All right, so I'm going to pull this 8 out. 16, limit as b approaches infinity of the integral from 0 to b of 1 over x squared plus 4 dx. This is arctan. So a is 2, so 1 over 2 times arctan of u over a, x over 2, from 0 to b. So 16 times the limit as b approaches infinity of 1/2 arctan b over 2 minus 1/2 arctan 0. 16 times 1/2. Arctangent of infinity is pi over 2. 1/2 arctan of 0 is 0. 16 times pi over 4 is 4 pi. Cool. Arc length. Find the arc length of the graph of this is just, why would I do any calculus? This is just a half circle. And actually it's a quarter circle. 0 to 4. This is just 1/4 of the circumference. Circumference of a circle with radius equal to 4. Circumference is 2 pi r. 1/4 of 2 pi r equals 2 pi. I'm not doing calculus. We could do the arc length formula, but that would be ridiculous of us. So that's it. Okay, and then true or false? If f is continuous on 0 to infinity, and the limit as x approaches infinity of f of x equals 0, then the integral from 0 to f of x to infinity of f of x dx converges. False. We had an example of that earlier. Let me go find it. Counter example was back at the beginning somewhere. This one converged. Let's see. 0 to infinity. Converged. Oh, come on. We had it somewhere. All right. Well, I'm going to use... Let me use a p integral. No, I'm going to use this one here. I know it says 0 to infinity, but the reason this diverged had nothing to do with the x equals 1 or the end of it. Like here's an example. We're going from 0 to infinity. No, wait, this is not an example. Where'd it go? This is an example. Here we go. Even though there's a discontinuity at 1, what they're saying is just because the terms are approaching 0 in the end doesn't mean the thing diverges. It has to decrease fast enough. So this is false because I could have any p integral where, let me go back to p integrals actually. Sorry. Kind of all over the place on this. P integral, I'm just going to write this. P integral where p is less than or equal to 1 makes this false. All of those diverge. 94. If f is continuous on 0 to infinity and the integral from 0 to infinity of f of x dx diverges, then the limit as x approaches infinity of f of x dx of f of x cannot equal 0. Again, this is false for the same reason. I know the p integrals are not defined at 0, but don't let that be a sticking point. Even if I like shifted them over one and had something that's decreasing, but just decreasing slowly, its terms could still be approaching zero. It's just not approaching zero fast enough to decrease. We'll talk more about this in chapter 9, but I'm going to say the same thing. P integrals. 95. If f prime is continuous on 0 to infinity, and the limit of f of x as x approaches infinity equals 0, then the integral from 0 to infinity of f prime of x dx equals negative f of 0. Let's see. So this is saying, let's just parse this out here without a bunch of limit notation. The integral from 0 to infinity of f prime of x dx should equal f of x evaluated from 0 to infinity, right? And that's equal to f of infinity minus f of 0. And f of infinity is approaching 0 minus f of 0. So yeah, that's negative f of 0. That seems true. What about 96? If the graph of f is symmetric with respect to the origin or the y-axis, then the area from 0 to infinity converges if and only if the other side converges. So here's origin symmetry. So let's say this converges. This area converges. This is symmetric, so this area would converge too. It has to. And if we had y-axis symmetry, say this converges, then this converges as well. Maybe there's a hump here. Yeah, that's true. All right, that was a long homework assignment. Please come see me in office hours if you have questions.